All right, let's talk Lewis dot diagrams. You should remember how to draw Lewis dot diagrams, Lewis dot structures, electron dot diagrams. Remember, there's a whole slew of ways to say it for single elements. You should know that already. They look like this. Remember, most number of dots is 8. We imagine the element inside of a box, but we don't actually draw the box. We can have 8 total. That's the maximum. 2 dots on each side. Remember, imagining the element inside of a box. Okay? And then we start in a regular pattern going around the element. Each side gets 1 electron before we double up. So that you should already know. If you don't, look that up first before going on. Otherwise, you're going to be super confused. So now let's try some ions. All right, so you have a handout that looks like this. So let's look at it. This is the front side of the handout. We're going to start here. So let's look at P, that's phosphorus. When we look it up on the periodic table, it has 15 total electrons and 5 valence electrons. Now, it is on the right side of the periodic table, so that makes it a non-metal. And let's draw the Lewis dot structure for the atom. Remember, we only draw valence electrons, not total, okay? Now, will the atom gain or lose electrons when it becomes an ion, and how many? Well, let's see. Remember, atoms are going to take the easy way. So this has 5. In order to be full, it would need to gain 3 or lose 5. So what makes sense? What would it do? Well, it would gain 3 versus losing 5. So what happens then is we add those 3 electrons. So now it has 8, but it has a charge, and its charge is 3 negative. Okay, why? Because it gained 3 electrons. And let's talk about why. Why is that charge 3 negative? Well, now it has 18 electrons, right? Because it had 15, it gained 3, it has 18. Well, it still has 15 protons. So 18 negatives and 15 positives gives me a negative 3. And I put these brackets here to indicate it's an ion. It has either gained or lost electrons, and I put the charge outside. Now, since it now has 18 electrons, that is the same number of electrons as argon has. So its electron configuration matches argon for this ion. So this phosphide ion matches the electron configuration of argon. All right, let's try another one. Beryllium. Well, it has 4 total, 2 valence. It's on the left side of the periodic table, so it's a metal. There's a Lewis dot structure of the atom. So now think, here are its options. It could gain 6 or lose 2. I wonder what it's going to do. It's going to lose 2. If you don't know for sure, literally look at the oxidation state. It's going to tell you. So when I draw it, I lost those 2 electrons. I don't put those dots anymore. I put brackets, and then I put the charge. How do I know the charge is 2 positive? Well, I could look it up on the periodic table, but also I have 4 protons. And since I lost 2 electrons, now I have 2 electrons. That gives me a 2 positive charge. So what noble gas does the beryllium ion have an electron configuration that matches? Well, helium, because helium is the noble gas with 2 electrons. All right, so for ionic compounds, when we do the Lewis dot structures, all we do is put the Lewis dot structures for the 2 ions next to each other. So when magnesium and sulfur bond together, we draw it like this for the Lewis dot structures. When it's sodium and chlorine, we draw it like this. See the charges, see the brackets, super important. All right, so now let's try covalent. So we're going to look at the back of the handout. All right, so let's look at Cl2, and I kind of have some steps outlined for you so that we could do it systematically. So first, draw the Lewis dot for all the atoms that are in the molecule. So Cl2. So that means I've got 2 Cls. So let's just draw the Lewis dot for the atoms. Now we're going to look for unpaired electrons. So see right here, I got one unpaired here, and I've got one unpaired here. So let me just see right here, this one is not paired. And see right here, this one is not paired. Match them up between the atoms. So I'm going to do this. I'm going to put Cl, and then I'm going to put those two. So I took this one and match them up to share them between. Now I'm going to have to add the unpaired electrons. So see how this chlorine had this pair and this pair and this pair, and this chlorine had this pair and this pair and this pair. Well, they can't like evaporate. They don't get erased. So I just put them there. I put them around the chlorine. Now I have to count the electrons. So if you look up here, when I counted, that's 14 total electrons. Let's check what I just drew. Well, it also has 14 total electrons. There are 8 around each atom. Perfect. That's exactly what I wanted, all set. So the 2 electrons that are between the atoms can be replaced with a line to represent the bond. So the line represents 2. So I could draw it just exactly as I drew it right here, or replace those 2 dots with one line indicating they're bonded. All right, let's try another one. First, we're going to draw a Lewis dot for all the atoms in the molecule. So this time we have H and Br. Look for unpaired. Here we go. Unpaired, unpaired. All right, so let's put the 2 atoms and put those unpaired electrons between them, pair them up to bond them. Now we have to add the unpaired electrons. Well, if you look, there was nothing else around H, but Br had some. So I add those electrons around Br. What do I do next? I count the electrons. Well, I started up here with 8. I have 8 down here. I have 8 around Br. 2 are around H. Well, that's perfect. That's what hydrogen needs. All set. Again, remember, I can draw them as 2 dots or change the 2 dots to a single line to represent the bond. Either of those are correct. Okay, now let's look at nitrogen. This one, they love to ask this one, so let's talk about it. So first, let's draw the Lewis dot for the atom. So I have 2 nitrogens. We're going to look for unpaired electrons. And here, look, see this time, unpaired, 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 more, unpaired, unpaired, and another unpaired. Oh, that was a terrible circle there. Okay. So in this case, each of these atoms has 3 unpaired electrons. So I'm going to match up the 3 from this one and the 3 from this one. So like this. So each one had 3. So 3 from this nitrogen, 3 from this nitrogen. Match them up. Now I need to add the unpaired electrons. So see, this nitrogen has 2, this nitrogen has 2. Okay. Our check is we had to count the electrons. So this was 5 and 5, so it was 10 total electrons. So when we count down here, these 6 count for both nitrogens. So 6, 7, 8, 6, 7, 8. But there's still only 10 total. Perfect. Remember, I can draw the electrons in the middle as lines. Every 2 electrons is one line. So 1, 2, 3 lines. One line for these electrons, one line for these electrons, one line for these electrons. So you could draw it either way. Now, for nitrogen, a lot of the time you will see it like this, with this pair of electrons on the outside. That's probably more closely what it looks like. But these ways are not inaccurate. This is just another way you might see it. All right, so now we're going to try this one, which has 1 C, 3 H's, and a Br. Oh my goodness. Whew, okay, so look for unpaired electrons. So here we've got unpaired, 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 unpaired. Carbon has 4. But then we have this one on bromine, this one on hydrogen, this one on hydrogen, and this one on hydrogen. So which element has the most unpaired? Well, that was carbon. So we're going to put it in the middle. Okay. We have 4 things to put around carbon. So let's put them around carbon and then pair the electrons in between. So that was 1 unpaired from carbon, 1 from hydrogen, 1 from bromine, 1 from carbon, 1 from hydrogen, 1 from carbon, 1 from hydrogen, 1 from carbon. Okay. Now we're going to add the unpaired electrons. So if I look, the only atom that has any unpaired electrons was the bromine. So add those around. Now I have to count the electrons. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have to count around here because my number of electrons has to be the same. So this is 2, 4, 6, 8, 10, 12, 14. I still have 14 electrons. There are 8 around carbon, 8 around bromine, perfect, and 2 around each hydrogen. Beautiful. So now I can draw the total structure with the lines or leave the dots. So remember, each pair, each 2 electrons can be drawn as a line. So these 2, when they're bonded, so between 2 atoms. These can't be lines because they're not bonded. They just got transferred down. So it could look like this. And see, in this one, I put the BR on the other side. So the location of the BR didn't really matter. All right, so you're going to practice by finishing your sheet and then you're going to turn it in. So hopefully this helps and you learn a little bit about doing Lewis dot structures.